This Unreal Engine 5.5 scene grows from 25 cubes to 100 to 400. The important number is not only the visible instance count. Every stage uses exactly one UInstancedStaticMeshComponent. Each cube has its own transform, but the component shares one static mesh and one material across the batch. In this lesson, we will explain why hundreds of repeated objects should not automatically become hundreds of actors, configure one instanced component, calculate centered grid transforms, add instances in local space, clear and rebuild the batch. Keep instance count separate from component count, and verify 5x5, 10x10, and 20x20 grids with automation, runtime logs, and real Unreal frames. An actor is a gameplay object with identity, ownership, lifecycle, components, networking hooks, and optional tick. That is useful when every object needs independent behavior. It is unnecessary when many objects only repeat the same mesh and material with different transforms. Instancing packs repeated geometry into one component-managed batch. The renderer can reuse shared mesh data and issue work more efficiently than a collection of separate static mesh components. Instancing does not erase every cost. Visibility, shadows, collision, per instance data, and overdraw still matter. But it changes the ownership model from hundreds of scene objects to one component plus transform records. The actor creates one UInstancedStaticMeshComponent, attaches it to the root, disables collision for this visual demo, assigns engine cube as the shared static mesh, and gives the component one dynamic material instance. The component count remains one at every stage. Use hierarchical instance static mesh when tree-based culling and large spatial distributions fit the workload. Use ordinary HISM for compact batches and simpler update behavior. Use separate actors when objects need unique gameplay logic or ownership. Choose the representation from behavior and rendering needs, not only from the number of visible meshes. Make instance transform converts a flat index into row and column. It subtracts half of side length -1, so the grid remains centered around the actor origin. Column controls X, row controls Y, and spacing is 120 Unreal units. Alternating cells use heights 55 and 100, creating a visible checker pattern. Every cube uses uniform scale 0.65. Because the calculation is a pure static function, automation can verify the first corner, the second column, the final corner, and the scale without starting a world or rendering a frame. Build stage first selects side length 5, 10, or 20. Expected instance count is side squared. The component clears its current transform array, loops from 0 to expected count -1, creates one local space transform, and calls AddInstance. The demo rebuilds the entire grid because it makes the teaching state explicit. In a live game, prefer targeted AddInstance, update instance transform, remove instance, or batch change operations when only part of the data changes. Avoid clearing hundreds of instances every frame. The correct update strategy depends on how often the batch changes. Stage 0 builds 5x5, which is 25 cyan instances. Stage 1 builds 10x10, 100 green instances. Stage 2 builds 20x20, 400 violet instances. Build count reaches 3. The shared mesh, material slot, and component remain the same. This distinction prevents a common misunderstanding. Instancing does not create 400 hidden actors. GetInstance count returns 400 transform records owned by one instance static mesh component. Each record changes where one copy appears, while shared render resources remain centralized. These are genuine game mode frames from the included Unreal project. The first shows 25 cyan cubes. The second shows 100 green cubes. The third shows 400 violet cubes filling the floor. The world space label reports one component and the matching instance count in every frame. Unreal captured these images through a scene capture component 2D and texture render target. They are not generated substitutes. Grid dimensions, alternating heights, color stage, component count, instance count, build count, and runtime logs all describe the same execution. The Unreal automation test passed with 1 success and 0 failures. It verifies side lengths 5, 10, and 20, counts 25, 100, and 400, default spacing 120, initial state, first and last grid corners, alternating height in the second cell, and uniform scale 0.65. The runtime then proves 1 component, 3 builds, all 3 exact instance counts, 3 native captures, final stage 2, final count 400, and valid true. Layout tests catch indexing mistakes quickly. Runtime evidence catches integration, material, camera, and rendering mistakes. The reusable pattern has 4 steps. Share 1 mesh and material through an instance component. Calculate 1 transform per visible copy. Batch additions and updates at the frequency the game actually needs. Verify instance count, bounds, layout, and final rendering. Add per instance custom data when the material needs controlled variation. Consider HISM for large, spatially distributed sets. Profile collision, shadows, culling, and update cost instead of assuming every batch is automatically cheap. For foliage, props, tiles, crowds, markers, and procedural decoration, this is a practical AI-friendly C++ foundation.